All right, so in this video, we're going to be looking at how to solve a system by using inverses. Now, in general, the process is going to be the same for larger matrices. The difficulty will be in calculating the inverse. So with a 2x2 system, there's actually a formula for calculating the inverse that we can use relatively quickly. Whereas if you're doing this for a larger system, finding the inverse will be more complicated. But our main concern with a lot of these problems is not so much which is the most computationally efficient method, but simply to understand the sort of concepts behind them, because inverses are very important particularly when we deal with proofs and other kinds of applications. The computational side is a whole other matter, and there are ways when you're doing computations to choose the solution method that is the most efficient for that particular problem. But here, again, we're focusing on not what is the most computationally efficient, but on understanding these basic concepts. Now, to solve the system here by using inverses, we're going to need to set up our matrices. So the first thing to keep in mind is our A matrix is going to be our coefficient matrix from the left side of our system. So that's going to be -3, 9, 3, and 2. And then our B matrix, AX equals B, for our system is just going to be the constants on the other side, 9 and 13. Now, the formula for A inverse is going to be 1 over A D minus B C, the determinant of our A matrix. And then assuming our original matrix was A, B, C, D going across the rows, we will change the positions of D and A, and then change the sign, but not the locations, of B and C. So for our particular example, A, B, C, D, this is going to be 1 over -3 times 2 minus 9 times 3. And then our matrix will become, flipping the locations of A and D, this will become 2, and this will be -3. And then the signs here will flip to -9 and -3. And if we simplify, -6 minus 27 is going to be 1 over -33. And then if we distribute, we're going to end up with -2 over 33. And 9 over 33 will reduce to 3 over 11. And then -3 divided by -33 will give us 1 over 11. And then -3 divided by -33 will also give us 1 over 11. Now, recall that if we have the matrix equation AX equals B, that X is going to be equal to A inverse times B. And so that's what we're going to do now. We're going to take our inverse that we found, and we're going to multiply it by our B vector. So, and if we do that matrix multiplication, we're going to get -2 over 33 times 9 is going to be -18 over 33, plus 3 over 11 times 13, which is going to be 39 over 11. And then we're going to multiply 1 over 11 by 9, so 9 over 11, plus 1 over 11 times 13, so 13 over 11. And when we simplify this, we can cancel out a 3 here. So that'll get us 6 over 11, which is a little easier than making 39 3 times bigger. And so we're going to end up with 39 minus 6 is 33 over 11 is going to be 3. And then 9 and 13 is going to be 22 over 11 is 2. And so the solution to our system is x is equal to 3 and y is equal to 2. Now we can go back and we can show that this is in fact the case by either going back to the original system or by solving the system by another means, such as by row reducing with the augment. But you should get the same answer either way.